for all exams, BYJU'S Exam Prep. For the first time, we, your favorite Anshul sir and me, together taking this Maha Marathon session. So guys, please do join and keep inviting your friends for this session. Anshul ji.
So happy new year all of you, and today we are starting this Maha Marathon and the subject is computer organization. So we have Satya sir and myself, so we will start this session and hopefully you are ready with your concept so that you can solve the questions, right? And guys, do share this session with all your friends so that we can have maximum students and they can take the benefit of this class. Yes guys, good afternoon everyone. Yeah.
Shivani, Suhas, Anvesha, Chandra Reddy, and everyone, very good afternoon, and I wish you a very happy, healthy and successful new year. So guys, if you want the session to be started, I want every one of you to please invite your friends. At least bring couple of your friends for this live session. Very useful session, very unique session is going to happen only on our BYJU'S Exam Prep platform. So we both together giving very important, most occurring, most expected questions of computer organization and architecture for this GATE 2022. So please do join quick. We are waiting for you all. And also mark your presence. Unnati, let's see, it depends completely on your speed. If you solve fast, definitely we can end up the session in less time, but it would happen minimum for 3 hours. Okay, so are you all ready? Are you all ready for this Maha Marathon session of computer science?
You can share the topic. So guys, I will be taking machine instructions and cache memory. Apart from this, I will be taking questions from addressing modes, and rest of the topics will be taken by Satya sir. Okay, and this session is going to be of 3 hours. So we are going to start very soon. So do share this class with all your friends in all the groups so that everyone can get the benefit. Yes, so great, all of you are saying yes, we are ready. Okay, so over to you, Satya sir. Now you can.
Yeah, definitely we will start, but let's see how many of you have invited and how many people join our session. Cache is very tough, Mayank. Okay, so let's make it easy. Let's make it easy with this session, Mayank. Definitely Anshul sir will make it easy for you and you will be confident after this session with cache memory. What do you say, sir?
Bilkul. Definitely guys, definitely I will make all these topics easy for you, so don't worry at all, right? And we have covered all the most frequently asked questions that you can definitely expect in the GATE exam. So don't worry at all, because we are going to provide you the approach, the best way to solve any kind of question based on these topics of computer organization. Okay. Yes, vision. I will. Yeah, it is the side effect of lockdown and COVID, right?
It is the side effect of knowledge. So do get married. No other diet is required for you.
Yes guys, only questions, but through questions we will explain you the theory as well. Don't worry at all. And it is going to be a complete revision.
Yeah.
Yes.
And guys, I hope you are all done with your preparation, right? Chandan Kumar Jaiswal, thank you so much. See, completely questions, no theory means through questions you will be able to understand every concept at what level you have to prepare for the GATE exam. And with all the questions that we covered today in the computer organization and architecture, you will be pretty confident for your upcoming GATE exam. Definitely. So complete revision. Definitely it is going to be complete revision. All the concepts of COA will be covered through questions. Okay. Cool stuff. Of course, yes, but live session would be more interesting, right? So please do stay in live. Chalo. So are we ready to start? Mayank, all the subjects will be covered. It is just the beginning. From today, 15 days continuous Maha Marathons will be happening. Okay?
PDF and show.
Yeah, PDF you will be getting in the Telegram group. Mayank, no question is bad. It is just your perception. It depends on your preparation level. So don't worry, just stay back till the end of the session. Definitely you would understand at what level you have to prepare, where you are lagging and where you have to focus. Okay? So shall we start? I want response from everybody. Also keep liking the session, keep sharing the session. Okay? No, video is not going to be private, Tahir. It would be left public only. But prefer to attend this live. Okay?
How many questions?
Don't see the count. Don't see the count. How many questions? Don't see the count. You just see, are we going to cover every concept in detail or not? Are we going to cover every model question in detail or not? That is only the idea. So with this session, you do not require any revision from this subject. That is what the motto. Okay?
Yes.
Okay. So Anshul sir, what do you say? Shall we start?
Definitely, sir. Definitely.
So guys, whom you want to start with?
Gives a thumbs up, everyone, in the comment section so that we can start the session soon.
Yep. So whom you want to start with? It's a very bad question, no? Definitely, any one of us can start. The motto is to cover all the subjects. So Anshul sir, if you permit, I'll start the session.
Definitely.
Okay? And please do help me if I stuck somewhere. Okay?
Duration is going to be 3 hours.
Minimum 3 hours, guys. But again, it depends. It depends on your Josh. If we feel like you are so interesting, definitely it can continue.
Okay, sir. Now you can start, sir.
Yep. Thank you.
Okay, guys. Get the maximum benefit of this session, right? We'll see you. Yeah, guys.
Yep. Thank you, Anshul sir.
And share the session. Thank you, sir.
Yep. Thank you. So guys, let us start the session. So it's been so long for me to take class from office, from smartboard. So let's see the first question. Before that, okay. Yeah, it is very boring slide, I know. But this is about me, and don't have any doubt, it is me only. So I am Satya with 14 plus years of teaching experience, and I have mentored more than 30,000 students. I am a research scholar. I am qualified in GATE couple of times, also qualified in SET and certified by Cisco. Sai Deepa, from today every day one subject will happen. Okay? Okay, so let me fix my mic. Right. So guys, this Maha Marathon session, which is a very unique session planned by our BYJU'S Exam Prep to benefit you guys, from today for 15 days, from 3rd Jan, for complete 15 days including your mathematics, every subject will be covered as a part of this Maha Marathon series. So do attend regularly. Okay? Vikash, definitely you can attend. You can just see, you can just check yourself how good you are. Okay? So here is the first question without doing any further delay. Here is the first question. Pick the incorrect statement from below for interrupts in 8085 processor. So the very starting question from IO interfacing topic. So I'll try to mention from which topic this question is for every question, and if I miss something, please do remind me, because there are some students who are new or who are 2023 aspirants. Upon their interest they are attending this session, so for their sake I'll try to mention the topic name also. So this is the question from IO interfacing. Pick the incorrect statement from below for interrupts in 8085 processor. Trap is a maskable interrupt. INTR is a maskable interrupt. INTR is a hardware interrupt. Trap is a hardware interrupt. So I want the response from everybody. It's not MSQ. Dilip, CS Learner, Navneet Kaur, Harshit Singh, Nishu Kumar, Rohan Kulkarni. So the majority is A. Of course, the majority here wins. Trap is a maskable interrupt. That is incorrect. Trap is called non-maskable interrupt. What is the difference between maskable and non-maskable, dear friends? If it is a maskable interrupt, its service can be delayed by the processor. Means after finishing the current instruction execution, the interrupt is serviced if it belongs to maskable category, and if it is a non-maskable category, immediately it should be serviced. So here trap is a non-maskable interrupt. Of course, INTR is a hardware maskable interrupt and trap is a hardware interrupt. Okay, and 8085 processor, just by looking that name you are thinking it is not in the syllabus, but what about interrupts? Interrupts is in the syllabus, right? It is the part of IO interfacing. Okay, so please do prepare that part also. That's what, from this session with these questions you will understand where you are missing and what topics you have ignored. Guys, GATE is very particular in finding the corner cockroaches. Means generally what topics you ignore, such topics there are much probability. Like if you see the last year GATE exam on ALU design, questions were asked. Generally it is considered to be very less probable, but it is asked in 2021 GATE. That is how. So do not ignore any topic. Okay, so let's proceed to next question. Which of the following statements is valid with respect to magnetic disk? So what is the topic? Secondary memory. So this is the question from secondary memory. As I told, I will try to mention the topic name also, so that it would be very clear for the students who are 2023 aspirants or who are just starters or beginners. Okay, so the question from secondary memory is here: which of the following statements or statements are valid with respect to magnetic disk? Only a track is contributed for each platter for each cylinder. Only a surface is contributed for each platter for each cylinder. Only a track is contributed from each surface for each cylinder, or only a sector is contributed from each surface for each cylinder. Options are so confusing, isn't it? So, like this, if you know the concept, the question is dead easy. If you are not preparing the concept thoroughly, definitely you will confuse in the options, right? So tell me, what is valid statement with respect to magnetic disk? Yep, guys, please try to use the question number. Try to use the question number while you give the answer, because it is continuous responses, it would be little difficult for me to identify for which question you are giving the answer. So I can see Muskan B, okay, Sambit B, Chandana B, so all are with B it seems. Mayank, I think Mayank has chosen option C. Rest everybody are choosing B. Sambhav C. So the right answer is option C. Option C. Why? Every platter will have two recording surfaces. From each surface, a similar track is contributed for cylinder. That is what the definition of cylinder. Suppose this is the spindle axis you see, and if I take two platters which is having four surfaces, assume these two together is first platter, platter 0. These two together is second platter, platter 1. So this is the top surface of platter 0, bottom surface of platter 0. Top surface of platter 1, bottom surface of platter 1. So let us number the surfaces. Surface 0, surface 1, surface 2 and surface 3. Okay, so here suppose every track is having 4 sectors. Let's say this is the first track of first surface, 4 sectors. Then the numbering would continue on the next surface first track. This is what the cylinder concept. Numbering will continue on the next surface. So all first tracks together, all first tracks of every platter or surface, every surface, but it is given only only a surface is contributed. Is the total surface, means one surface is having, let's say 100 tracks, all 100 tracks are contributed for every cylinder? No. So what is the right answer? One track from every surface. Only a track is contributed for each surface for each cylinder. That is what the right answer. Okay. Mahesh, for partially correct chosen options, there is no award of marks in MSQ. MSQ you should give all correct answers, then only you will be awarded mark, otherwise there is no negative marking. MSQ, NEIT do not have negative marking, only MCQs have negative marking, and MSQ don't have partial award of marks. Okay. Right. Next question. What is the correct ascending sequence of priorities for interrupts in 8085 processor? By looking the processor name again, don't feel like it is microprocessor subject or it is out of the syllabus. Look at this, interrupts, which is part of IO interfacing. So there is a probability for getting a question from interrupts, guys. So it is better to cover this topic. So again the topic is from IO interfacing. The question is from IO interfacing topic. So what is the correct ascending sequence of priorities for interrupts in 8085 processor? Use the question number for giving the answer, please. INTR, trap, RST. Ascending means from lowest to highest you have to choose. So which has lowest priority in this, which has highest priority in this. Just now in the very first question we have discussed, trap is a non-maskable interrupt. This is having highest priority. Then RST, then INTR. So the order would be 1, 3, 2. Option D would be the right answer. Okay. So if you do not know something, at least with this session, please get to know. Please make a note. You please maintain your own scorecard. Like from 1 to 50, 1 to 60, you just give the numbers. For every question, if you answer correct, you award yourself. Otherwise, you please mention the note why the question is, why you are unable to answer that question properly, correctly. Is it because of lack of subject knowledge, or is it calculation mistake, or is it you did not read the question properly? So what is the reason? This is the way how you can identify your mistakes on your own. Okay, so these sessions should be motivating you or training you in that way. So try to identify where you are lagging. Okay, next question on your screen. Consider a disk pack with 64 surfaces. Very good, very good. So after many days I see more than 100 students are watching. Very good. Congratulations to all, and I want this to be doubled in very soon. So it all happened because of you, only by you. It can happen only by you guys. If you think you should bring your friends, definitely you can bring. So please do read this question number 4. Consider a disk pack with 64 surfaces, 32,768 cylinders per surface, 2048 sectors per track, 512 bytes of data per sector. Okay, then what is the sector address width? So use the question number for giving your answer. Quick, you just have 30 seconds for giving the answer. Guys, in the GATE kind of exam, you should be fast and accurate. Speed with accuracy will give you the rank. With practice, you can improve that. So please give your answer for the question number 4. Okay, Sambhav is giving option D is the okay. Oh, Satya, please check it. Satya Chakrani, GATE postponed, update came just now. Okay, we are checking on it. I'll give the latest update. Satya, उधर चेक करो लैपटॉप में. Option D, option D, option D. Great, great, great. Okay. Option D, option D, option D. Right. Let's see. The right answer is option A. Why? Why? we want to find the sector address. If we are having 2 raised to I sectors, then I bit address would be there for every sector. Right? Let's count how many number of sectors in total. There are total 64 surfaces. on every surface there are 32,768 cylinders. On every cylinder there are 2048 sectors. We just want number of sectors, right? So if we convert this into 2 raised to, it is 2 raised to 6, 2 raised to, what is this, 15, 2 raised to 11. So this is 2 raised to 32 sectors. Oh my god, that means 32 bits. So do you think you are correct? Come on, I want the address in bytes. So you should read the question carefully. I want the address in bytes. So if you solve it partially and if you select 32 and you think yes, I have answered correct, but ultimately it is going to be wrong answer. And as it is MCQ, there will be negative marking also. So you should read the question properly. Okay, so as 32 bits means 4 bytes, the right answer would be 4, not 32. Exam? Guys, as per our information, admit card got postponed. As of now, regarding exam postponement, there is no official news. Only admit card got postponed. Okay, there could be chances, as admit card got postponed, there could be chances, but there is no official information. So please think that the exam is in the February and get ready. What's going wrong? If you get more time, that is good for you only, right? So there is nothing wrong in preparing upfront, right? You can prepare more questions and we do this kind of Maha Marathon sessions again, right? So keeping that the GATE exam is getting postponed, don't stop your preparation. Okay? Chalo. Next question. Again from secondary memory. A disk has 16 equidistant tracks. Okay. The diameters of the innermost and outermost tracks are 1 centimeter and 16 centimeter. Fine. The innermost track has a storage capacity of 5 megabytes. The total amount of data that can be stored on the disk if it is used with a drive that rotates it with constant angular velocity. Constant angular velocity. I think everybody are aware of CLV and CAV. Constant linear velocity and constant angular velocity. The disk can be designed in these 2 ways. The motor rotation would vary based on this CLV and CAV. Okay, Harshit is giving some update for us. Actually, they are again giving change of city. Okay, probably. Fine. So what is your answer for the question number 5? Quick guys, if you keep answering fast, definitely we can cover more number of questions, right? And also don't forget to share. Please do share the session information to all your friends. Let them join for this live session. And also keep liking. Guys, I see 104 people are watching, but why only 69 likes? Please do like the session, guys. Yes, Akshay, I am going to explain. Please do like first. So what is this CLV and CAV? If it is constant angular velocity, then there would be suppose if this is the surface you see, if it is constant CAV based design, then there would be varying density but fixed size on every track, whether it is a small track or a big track. You see, the innermost track is very small, the outermost track is bigger one, but as the density changes, means in the simpler terms you can say, in the innermost track there would be less distance between the sectors. In the outermost track there would be more distance between the sectors, but it is maintained in such a way that every track of that surface has equal number of sectors. This is the CAV design. If it is CLV design, then it is reverse. Varying size, fixed density. So innermost track will have less number of sectors, outermost track will have more number of sectors. Here the question is asking us to consider CAV, constant angular velocity. So we will have fixed size. How many sectors total? 16 sectors. What is the innermost track size? 5 MB, means total sectors together we have we can say 5 MB. So as there are 16 sectors, every sector size is 5 megabytes. What would be the total size? 80 megabytes. So option A would be the right answer. Okay, Harshit, got little idea? Right. Let's proceed to next question. Question number 6 on your screen. A hard disk has 32 sectors per track, 8 recording surfaces. The address of a sector is given as CHS. C means cylinder number, H means head number, S means sector number. Okay. If the address C, 10, 10 corresponds to sector number 1354, then what is C value? Come on. Harshit, Navneet, Anvesha, Chandan Kumar, Jaiswal, Sandhya, everybody. I want response from everybody. Please make the session interactive by giving your responses for every question and keep posting your doubts. Feel free to ask all your doubts. I will be very happy to answer all your doubts to my possibility. And guys, it is a marathon session, so you require some patience, because if you stay back till end of the session, then only you can assess yourself how good your preparation is, how well you are prepared with. If you just look at 4-5 questions or some questions and if you leave, then it's not going to be a perfect assessment. So guys, please have some patience. If you could not answer some questions, don't worry, because it's a process of learning. And if the GATE exam, as some students were predicting, if it gets postponed, you will get even more time to prepare, even more time to learn. But you should know what to learn. That is the point, right? So don't hesitate and don't get demotivated as you give wrong answer, as you don't know the topic. Okay, learn. It is the time to learn. Right. So what is the answer for the question number 6? Quick, you can't take more time for every question. We know the consolidated sector number can be found with a simple formula. Guys, if you don't know this, please make a note of it. It's very important, very useful formula. If CHS is given, then how do you get the sector number? It is C multiplied by total number of surfaces multiplied by total number of sectors. Total means number of sectors per track, not total. Plus H multiplied by number of sectors per track. Plus S. So this is the simple formula. Now we are already given with the sector number. What is that? 1354. That is equal to C we are supposed to find out, and number of surfaces. How many? 8 recording surfaces. And number of sectors per track, 32. Plus H is given, so this is CHS. H is given 10, number of sectors per track, plus S is given 10. So just evaluate it. It is 1354 is equal to 256C plus 320 plus 10, which is 330. So here we can say 256C is going to be 1024. That means C is 1024 divided by 256, that is 4. So option A would be the right answer. Good, Harshit. It's a good practice. Keep it up. Next question. Certain processor has vertical micro instruction format. What is the topic? Guys, you please name from which topic this question is. I'll see how many of you identify the topic correctly. Consider a processor that has vertical micro instruction format containing 10 separate control fields C0 to C9. Each CI activates any one of the NI distinct control lines. So what is the minimum number of control bits required in the control field? Oh, PSW. Acha, in COA we are discussing OS questions, it seems, Mahesh. Huh? Good, good. Okay, now you give me what is the answer. Very good, you identify the topic. That is the biggest challenge. You identified the subject and the topic correctly means halfway you are qualified in the GATE exam. Come on. It is vertical micro instruction format. If you are having 2 raised to I control signals, as we use encoder, it reduces for I bits. This is what stored in the control memory. If it is a horizontal, 2 raised to I bits are supposed to be stored. So this is what representing the number of bits every signal is representing. So first 4 signals require 2 bits, again 4, 2 bits, 3. So here how we can say, if this is 2 power I, we want I. In the other way, just apply log to all these values individually with the seal. So it is again 2, and 11 would require minimum 4 bits. 9 4 bits, 16 4 bits, 7 3 bits are enough, 1 bit is enough, 8 3 bits, 22 5 bits. So just sum all. 2 plus 2, 6 plus 4, 10, 14, 18, 21, 22, 25, 30. Harshit, more efficient in terms of speed. We can generate control signal faster just by fetching the control word, means the number of bits from the control memory. The control signal is ready. But if it is vertical, when you fetch, you will be getting the encoded bit form. Again you have to decode it. So it would require some time. And hardwired is even faster than horizontal because it directly sends the signals to these hardware devices. Right. Chalo, next question. A microcontrol unit is having control word in the following format: condition, control field information, next address. If it has to generate 85 control signals, next addresses are selected based on 25 conditional flag information. If the control memory is having 4096 control program of size 8 words, what is the size of the control word in vertical microprogramming? Yes. Guys, keep liking the session, keep sharing the session. If it is following vertical microprogrammed design, what is the size of the total control word? It has to generate 85 control signals. So how many bits? Quick. Suhas says C, De Villiers says C. Okay. What about others? Guys, make the session interactive. Give your answer for every question with the question number. I want response from everybody. If you just sit idle and watch the session as if you watch a movie, it would not be interesting and you cannot learn. Chandan says 24. That means again C. Vision. What 7? 7 bits. Okay. Fine. See here. Next address, that is indicating the length of the address or width of the address. That is based on how many words we have. How many we are having? 4096 or 8. What do you take? The control memory is having 4096 control program of size 8 words. So do you take 8 into consideration or 4096? 0, cool, no idea. Okay, very good. Super. This is what? 2 raised to 12. So 12 bits. Control field information. Which control signal to generate? Here we have. Just now we have discussed, as you have 85 control signals, you just apply log to it with the ceil value. So you will get 7 bits and then for the condition we have 25 flag information. So again log 25, that is going to be 5 bit. So summation of all 5 plus 7, 12 plus 12, 24. Very good. Next, question number 9. The disk contains 200 tracks. The rotation speed is 2400 rpm. Track capacity is given. Number of sectors per track is given. If so, what is the average latency time? De Villiers, very good question. One word, see, in the memory design we say 128 by 8. What does this mean? There are 128 words, each word length is 8 bits. So you don't take 8 bit into consideration when you find number of words, because the address is not given for every bit, the address is given for every word. In the same way, there are 4096 by 8. That is what the information given. If horizontal, what would change? 85 we will take instead of 9, because 85 signals means 85 bits would be required. Only that will change. 9th question, Vision says D, Saksham says D. Okay, right. Here we want latency, average latency. What it is? It is the time to position required sector. What we call it as rotational latency. On an average, how much rotation is required? 360 degree or 180 degree? 180 degree rotation means half rotation is required. So the time taken for this is equal to half rotation time. So how we find half rotation time? We have got the rotational speed as 2400 rotations can be covered in 1 minute, that is 60 seconds. So one rotation can be covered in 60 divided by 2400. This is 1 by 40. I can say 25 milliseconds. This is for one rotation. This is for one rotation. But what is rotational latency? Half rotation. Half rotation time. So that would be 25 by 2, 12.5 milliseconds. Okay. Next, how many 128 by 8 bit RAMs are required to design 32K by 32 bit RAM? Yes, please. How many 128 by 8 bit RAMs are required to design 32K by 32 bit RAM? So we have digital logic expert Anshul sir also here. So definitely sir could have taught you, while designing memory we will have 3 types of design: horizontal expansion, vertical expansion, matrix expansion, right? Here this fall under matrix expansion category. Means you see the number of chips is different and each chip size is also number of words different, word size is also different. So it is a very simple formula. We want 32K by 32 size RAM, but we have only 128 by 8 configuration. Just do the division. 32K into 32 divided by 128 by 8. So this would be 1K, means 1024. So if I need to proceed further, guys, first you tell me what is your score out of 10. 10 questions are over. So out of 10, how much did you score? Dear friends, please tell me. Please update your score in the chat box. 26 से आप start करो अभी, बच्चे बोर लग रहा। आप आइए, एक 10 क्वेश्चन कराइए, फिर मैं लेता हूँ क्वेश्चन नंबर। ठीक, चलिए। Okay, 7, 6, 5. Just be honest. Be honest, because it's nothing wrong doing mistake. Correcting your mistake, identifying your mistake is the most appreciated thing. But we should not repeat the mistake. That is the point. Very good. 4, 6, 7, 5. Now you are about to score, able to score 4 or 5. It's good. It's good. Okay. Okay. Great. Great. So now I have taken 10 questions. Now your favorite Anshul sir will join. He will make you solve some more questions. Again I will join. So guys, if I need to invite, if you want me to invite your favorite Anshul sir, I want every one of you to please like the session, share. I don't understand why you people are not sharing. Such a wonderful session is happening. Such useful session is happening, and we are doing this session exclusively for you guys, for your benefit, right? Sir, explain question number 10. Unnati, see, if suppose this is the memory chip, just try to understand. I'll try to give a very simple explanation. We have 128. Suppose you just understand, this is one 8-bit RAM. Just one 8-bit RAM means 1 byte RAM. We have such 128. This is 128. But we want 32K, and every word size I want 32 bits. It is just like if one mango costs 5 rupees, 5 mango costs how much? It's a simple aptitude. Okay? So, let me invite Anshul sir. So let me invite Anshul sir to take this session forward. Again, after some time I will join. Anshul sir, please welcome. So share aa gaya. Sir, please take the charge. See you guys after some time.
Yes, hello everyone. So I hope so far you have enjoyed the session. 10 questions are done and now I will be taking next 10 questions. Okay, yes guys, do share the session as much as you can, right? So before starting, let me introduce myself. Those who don't know, my name is Anshul and I have 2+ years of experience. In GATE 2020 I have secured All India rank 294. I have cracked ISRO and NILET exam, mentored more than 1000 students as of now, and these are my area of expertise. Thank you so much for your support and for your love, everyone. KGF. Okay, so let's start. You know, this marathon is going to we have started this, and for all the subjects we will be taking these sessions. Okay, this is the first question. I hope guys you can solve this question. Yes, everyone. Thank you so much, all of you. Yes, along with the questions I will explain you the theory as well, so that you can understand the concept and you can solve these type of questions easily in the GATE exam. Okay, don't worry at all. I will explain you each and every question with the best possible way. Yes guys, do solve this question. I hope all of you can solve this. This is not a difficult one, but yes, in the GATE exam sometimes we may commit silly mistake in these simple questions, simple, easy to moderate questions. Yes, Sai Teja, that will be available to you, don't worry at all. If you can watch later on, you can watch it. Okay, but it will be better if you attend live and you can ask your doubts as well. So we are getting the answers now. 26, 24, 24. Okay, most of the students are getting 24-bit as the answer. Let's solve this question now. Okay, so a processor, just a minute. A processor has 50 distinct instructions and 16 general purpose registers. Each instruction in system has one opcode field, 2 register operand field, and a 10 bits memory address field. The length of the instruction is of dash bits. Now, if it is given to you that a processor has 50 distinct instructions, that means this processor can support 50 distinct type of operations. We can say, for example, addition, multiplication, division, and there can be so many, right? So 50 distinct instructions means it can support 50 distinct operations. Okay, so if we consider the instruction format, let's say this is your instruction and it is given that you have the opcode field. You have the opcode field. Apart from that, you have what? 2 register operand field. 2 register operand field are there. Let's name it R1. Let's name it R2. And then you have one memory address field. So you have one memory address field also. Clear? Now, when it says 50 distinct instructions, so how many bits required for opcode? Yes guys, how many bits required for opcode? So you have to take log 50. If 50 distinct instructions it can support, so log 50 base 2 and seal of it. So we can easily calculate it. What should be the number of bits? So if it is 50, so we know this 6 bits are required for this. 6 bits are required for this. That means your opcode is having 6 bits. Now you have 2 register operand field and 16 general purpose registers you have. If you have 16 general purpose registers, then how many bits required for, for each register? So you can again take log 16 base 2, that will be 4. So 4 bits here, 4 bits here. Clear? And then you have 10 bits memory address field. So 10 bits memory address field will be there. So if you add all this, 10, 20, 24 will be the answer. That is, this is the length of the instruction, or you can say size of the instruction, that is 24 bits. So 24 is the correct answer for this question. Is it clear, everyone? If you have any doubt, please ask. All clear so far? Yes, very good, all of you. Yes, 24 is the correct answer. Okay, so next question on your screen now. Yes, guys, solve this question now. So we are going to increase the level. Question by question, we will be increasing the level also, okay? And all the types of the question, variety of the question we will be covering here. Some previous year questions also I have added here. Yes, Sai Teja, that will be available. Yes, guys, quickly solve this question. Laddu question, yes, Satyam. Yes, guys, quickly. These questions should hardly take 1 minute, I would say, 1 minute to solve. 9 bits, 9 bit. Okay. Let's read the question first. A processor has 20 distinct instructions. Again, the same concept. Opcode, you can find out opcode, the bits required for opcode. 32 general purpose registers, 24-bit instruction word has an opcode, 2 register operands, and an immediate operand is given. Right? And immediate operand is given. The number of bits available for the immediate operand field you have to evaluate. So, see, you can see the concept is same, right? They can just make the questions in a different way, right? So the concept is same. If you can understand the concept easily, you can solve these type of questions. 24-bit instruction, right? You have the opcode field. What apart from that, you have 2 register operands, R1 let's say, and let's say R2, and then you have this immediate operand field, and you have to find the size, the number of bits required for this immediate operand field. Clear? So 20 distinct operations. How many bits for opcode? 5 bits for opcode, because if it is 4, you can have 16, maximum 16 distinct instructions. Here it is 20, so 5 bits. Then 2 register operands, 32 general purpose registers you have. So how many bits? 5 bits for register field, and then you have immediate operand. So if you can add all these, 15, 24 minus 15, it is going to be 9. 9 is the answer. 9 bits are available for immediate operand field. Is it clear? I hope you know what is immediate operand. You can directly write the constant value there. Using the bits, you can directly write the constant value there. Is it clear, everyone? If you have any doubt, anyone, please ask. All good? Okay, let's proceed then. And this is the next question. This is the next question for all of you. Read this question and answer this. Yes, guys, and do share this session with all your friends, those who are preparing for GATE exams, so that everyone can get the benefit of this. And I'm literally telling you, if you attend all these marathon sessions, definitely, even if you haven't covered this subject at all, still if you are attending this marathon session, you will get a lot of benefit. You can solve easy to moderate questions easily. That is the benefit of this marathon session. Yes, let's see how many students will answer this question correctly. Question is clear, all of you? How many memory locations are required to store each instruction in the memory? Yes, I'm waiting for the answer. Let's see how many of you will answer this one correctly. Anyone getting the answer? Yes, Kirti, this is the first subject of marathon. Today is the first day. Yes, everyone, quickly solve this. Sambhav is saying 1 should be the answer. Okay. Kashish, 12 bits. Read the question. How many memory locations are required? And you are saying number of bits. Yes, guys, quickly. Consider a system which supports only 2 address instructions. And supports word addressable memory. It is given in the question that it is supporting word addressable memory. That means at every memory location, or you can say at every memory cell, you have one word stored there. Yes or no? You have one word stored there. The memory has total capacity of 2 MB with word size of 4 bytes. One word is equal to 4 bytes. Yes or no? If the total capacity of memory is 2 MB, so if I want to represent in word, so I can divide 2 MB 2M by, you can say 1 byte is equal to 1 by 4 words. So it is going to be like this, words. Now if you can solve this, this is 2 raised to power 20. This is going to be 2 raised to the power 19 words. Is it clear so far? 2 raised to the power 19 words will be there. You can say the memory capacity in terms of words. The system supports 350 distinct instructions. Okay, so let's consider this. This is given to you, right? This is given to you, and it is saying only 2 address instructions. Fine. This is your opcode field. This is your opcode. 350 distinct instructions. That means how many bits required for opcode? How many bits required for opcode? 9 bits. 9 bits are required because 2 raised to the power 8 is 256. So 9 bits are required. 2 raised to the power 9 is 512. Then you have, let's say, this address 1 field, address 2 field. Clear? As it is saying 2 raised to the power 19 words, that means 19 bits will be there for the instruction. 19 bits will be there for the instruction. Yes or no? Now it is saying how many memory locations are required to store each instruction in the memory. Yes. What will be the answer? Yes, Unnati, 2 address instructions. See, if it is saying 2 address instructions, that means in an instruction format we can have 2 address fields. Maybe it can be register field, maybe it can be memory address field or something else. Clear so far? Any doubt, anyone? Okay, few students are saying 9 memory locations we have to access. Some are saying 19. Okay, let's see this. So how many memory locations are required to store each instruction in the memory? If you carefully see this, one instruction is taking how many? 19 bits, right? And as it is word addressable memory, so you can see 4 bytes. One word is equal to 4 bytes, that means 32 bits. Clear? So opcode we have 9 bits, right? What else? I'm sorry for that. This is not 19. I'm sorry. 2 raised to the power 19 words we have the memory capacity, so 19 bits will be the address size. Okay, 19 and 9. So total instruction size will be, this is going to be 38 plus 9, that is going to be 47 bits. 47 bits. Is it clear? Is it clear? Because this is the instruction size, not memory address. This is the instruction size. If you have 2 raised to power 19 words, that means 19 bits will be there for address field. So 19 plus 19, that is, yes, de Villiers, not instruction size. This is going to be address field. 38 plus 9, 47 bits. Now, if you have this memory, if it is given that it is word addressable, so here you can store 32 bits, but the instruction size is 47 bits. That means another remaining 15 bits you have to store here. Remaining 15 bits you have to store here. That means each instruction is taking how many memory locations? 2 memory locations, one for this one and one for this one. So 2 memory locations are required to store each instruction in the memory. Is it clear? 2 will be the answer. 2 is the correct answer. 2 is the correct answer. Is it clear, everyone? Yes, Nishu, 2 is correct. Yes, Anvesha, answer is 2. 2 memory locations are required. Clear? Let's proceed to the next question now. So there are 3 questions for this given question. You have to find all these. So you can answer this question in a comma separated value. Yes, guys, quickly answer this. Because if I say 2 raised to the memory capacity is 2 raised to power 19 words, that means how many addresses will be there? 2 raised to the power 19 addresses will be there. Clear? Why? Because it is word addressable memory. That means at every memory location you have 1 word stored. So 2 raised to power 19 words, that means 2 raised to power 19 addresses will be there. If 2 raised to the power 19 addresses will be there, that means address size will be what? Address size will be 19 bits. This is the basic concept. You should understand it. Is it clear, Vikas? Okay. Yes, guys, what should be the answer? Okay, Suhas is saying 82416 MB. De Villiers is also saying 82416 MB. That's good. Okay, many students are getting the correct answer. Let's see. A digital computer has a memory unit with 32 bits per word. So it is given to you, one word is equal to 32 bits. The instruction set consists of 240 distinct operations. This is your opcode, right? And 240 distinct operations, that means how many bits required for opcode? 8 bits are required for opcode, because 2 raised to power 8 is 256. All the instructions have an operation code, opcode you can say, and address part allowed for only one address. That means you have only one address field. Now each instruction is stored in 1 word of memory. One instruction is consuming 1 word of memory. 1 word we know that is 32 bits, and it is not given here whether it is word addressable, byte addressable. So by default we have to address it as byte addressable. So that means the instruction size is 32 bits. 32 bits. Clear? And here we have this address field. Okay, how many bits are needed for opcode? Already calculated, that is 8 bits. 8 bits. How many bits are left for the address part? So 32 minus 8, that is going to be 24. What is the maximum allowable size of memory word addressable? So what will be the size of the memory? If address size is 24 bits, so that means maximum allowable memory will be 2 raised to the power 24 word addressable. So we have to answer in words. So it is going to be, this is, you can write 16 mega words. Is it clear, everyone? Any doubt? If you have any doubt, please ask. If you have any doubt, please ask. All clear? Chale aage. Okay, let's proceed. Just a minute. Okay. Yeah. Next question. Yes guys, quickly solve this. Yeah, it should be 16 megabytes. Yes, megabytes. Byte addressable hai, megabytes. Yes guys, solve this question. So this question is based on expanding opcode technique. If you know the concept, you can easily solve these type of questions. Yes, quickly solve this. How many 2 address instructions can be formulated? Keep sharing guys, keep sharing the session. Yes, what should be the answer for this question? De Villiers is saying 12 should be the answer. Okay, we'll see. Noob is also getting 12 as the answer. Yes guys, quickly answer this question. Okay, so let's solve this question now. Consider a system which supports 2 address and 1 address instructions. Both it has 24-bit instructions with 10-bit addresses, right? So let's consider both. Here we have, let's consider the format of 2 address. Opcode will be there, right, and 2 address field will be there. Similarly, it supports 1 address also. So let's talk about that. Here it is opcode and here it is only 1 address field. 24-bit instructions. So 24-bit is the instruction length and here it is also 24 bits. Clear? And 10-bit addresses. 10-bit addresses. So we can say, let's name address field 1, address field 2. So here it is 10, here it is 10. Here also it is 10. So 24 minus 10 it is going to be 14 and here 24 minus 20 it is going to be 4. Clear? Now it is saying if there are 4096 1 address instructions, then maximum how many 2 address instructions can be formulated? Yes guys, what should be the answer? Okay, everyone is getting 12. So here always in these kind of questions you have to consider first the format in which the opcode length is less. So as you can see here, so if you talk about maximum opcodes, so it is going to be, if 4 bits are there in the opcode field, so 2 raised to the power 4, that means 16 opcodes will be there maximum. Clear? Out of that we have to find how many we have the maximum 2 address. So let's assume it is X. So used opcodes will be X. Now how many will be the unused? 16 minus X. 16 minus X will be the unused opcodes. Now we can use these unused opcodes to formulate the 1 address instructions. So here it is. Out of 14 already we have used 4 bits. So 4 bits already used, but 10 is still remaining. That means still we can form 2 raised to the power 10 combinations along with this. So it should be 16 minus X multiply 2 raised to the power 10, because 4 bits I have already used here in the 2 address, right? Now 10 is remaining, so 16 minus X into 2 raised to the power 10 opcodes we can formulate here. Clear? and that is equal to 4096. That is equal to 4096. So if you can solve this, this is what? This is 2 raised to the power 12. Cancel out. This is going to be 2 raised to the power 2. That is 4. So 16 minus x is equal to 4. So x will be equal to 12. X will be equal to 12. So 12, maximum 12 to address instructions we can formulate here. Answer is 12. Very good, all of you, those who have answered this question correctly. Okay, let's proceed further. Yes, guys. Now in this question, it is, we have included 3 address also now. In the previous question, it was only 2 address and 1 address. Now it is 3 address, 2 address and 1 address. So just one level above. Yes, De Villiers, yeah, you are right. If they say in bytes you have to answer, then you have to answer in bytes. Otherwise you can answer in words also. So that will be given in the question. Okay, don't worry at all. They will provide you the units also. Don't worry. Yes, guys, quickly solve this question. You can use calculator also. Okay, Rahul, after this question I will take that question again. Okay, if you have any doubt, I will consider that again. Yes, everyone, quickly solve this. These type of questions are frequently asked questions. Okay, even if you haven't covered this subject yet, don't worry at all. If you can cover all these questions which we are taking today, definitely you will be scoring well in this subject. Because in COA, they are not going to ask you difficult question, all the difficult questions, right? Some questions will be there which is going to be from easy to moderate level, and that is the level. This is the level. Okay, we are getting the answers now. 1020, 508. Keep sharing, guys, keep sharing, keep liking the session as much as you can, because we are having this session just for you guys, so that you can practice more, you can get an idea what kind of questions you can expect. Okay, so let's solve this question now. Most of you are getting the correct answer. Consider a system which supports 3 address, 2 address and 1 address instructions. It has 32-bit instructions with 8 bits addresses. Okay, now if there are 254 3 address instructions and 1024 1 address instructions, then maximum how many 2 address instructions can be formulated, right? Again, the same technique we can apply. So here we have this 3 address field, here we have this 2 address field, and here we have this 1 address. Okay, 3 address instruction, 1 address, 2 address. Okay, now here opcode, 32-bit is the size, the length of the instruction, that is fixed. So I think you know the concept. If the instruction size is fixed, variable opcode will be there. Okay, variable opcode will be there. So that's why we are getting the variable opcode bits. So here we have in 3-bit address, 8-bit addresses are there. So 8, 8, 8. So that is 24, 32 minus 24, that is 8. Here also 8, 2 addresses we have. So 8 bits, 8 bits. This is 16, 32 minus 16, 16 bits we have for opcode. Clear? And what about this one? Again 8 bits. So 32 minus 8, 24 bits we have for opcode. 24 bits we have for opcode. Clear? Now again you know the concept. From where to start? The instructions which are having the opcode bits less, we have to start with that. So we have to start with 3 address. So 2 raised to maximum opcodes, 2 raised to the power 8. That means 256 maximum opcodes will be there. But we have 254 3 address instructions. So used are 254. If you subtract from it, unused opcodes will be 2. Unused opcodes will be 2. Clear? Now using these unused opcodes, you can further have many 2 address instructions. So here it is, we can use this. Out of 16, 8 bits we have already used. Now remaining are 8 bits. So how many combinations we can have? So it is going to be 2 multiply 2 raised to the power 8 combinations. These many opcodes we can have maximum 2 address, right? But here it is saying we have to find maximum. So let's assume out of this we are using X. Out of this we are using X. So this is maximum. We are using X. So how many unused will be there? So we can say 2 raised to the power 9 minus X. Or you can say 512 minus 6, correct? Now we can use this unused for 1 address. We have 1024 1 address instructions. Out of 24, already 16 is used. Already 16 is used. So now how many remaining? 8 are remaining, right? So we can use this unused opcodes 2 raised to the power 9 minus X multiply 2 raised to the power. Out of this 12 are still, 8 are unused. So 2 raised to the power 8, and that is equal to 1024. That is equal to 1024. So this is 2 raised to the power 10 divided by 2 raised to the power 8. That is going to be 2 raised to the power 2. That is 4. So 2 raised to the power 9 minus X is equal to 4. X is going to be 512 minus 4. That is 508. X is going to be 508. Is it clear? Yes. Good afternoon, Nisha. So 508 is the correct answer for this question. 508 is the correct answer. These many maximum 2 address instructions we can formulate. So in 29th question, I think one student is having doubt. Yes, this one. It should be 16 bytes. Okay, then we can convert it into words. If they mention in the question that answer has to be in words, then you have to answer in words. Otherwise you can answer in bytes only. 16 MB, or if you answer in words, it is going to be 4 mega words. Clear? Is it clear to all of you? I hope it is clear, Rahul. Shall we proceed to the next question now? Okay guys, so let's see this 32nd question. Yes, solve this. Now here in this question, if you see, we have 2 address, 1 address and 0 address instructions. Okay, so it is given that 6 bits addresses we have. It is given 10 2 address instructions, 364 1 address, 1280 0 address instructions. You have to find the size of the instruction now. In the previous question, size of the instruction was given to you, right? But now you have to find the size of the instruction. So that is the change here. Yes guys, quickly solve this because we have so many questions to cover. Yes guys, what should be the answer for this one? Question number 32. You can solve along with me. I'm also solving this question. So to save some time, okay, to save some time, 2 address, 1 address, 0 address instruction. So here we have the format for 2 address, opcode and 2 address field. Here we have opcode and 1 address field, and here we have just the opcode. There is no address because it is 0 address. We are talking about 0 address instructions. Clear? Now here it is opcode. We have to find the instruction size. Here we have to find the instruction size. So let's say it is I. Let's say it is I. Okay. Now it is given that we have, the system has 6-bit addresses. So 6 here, 6 here. So how many will be, how many bits will be there for opcode? How many bits will be there for opcode? So it is going to be I minus 12. correct? I minus 12. What about this one? 6. Here it is I, so it is going to be I minus 6, and here it is just I, because we don't have address field in 0 address. Clear? Now it is given that this is the smallest one, so we have to start from here. This is the, we can have maximum 2 raised to power I minus 12. This is the maximum. Now out of this, how many we are using? 10 only. We are using 10 only. We are using 10, 2 address. Clear? Now these are going to be unused now, because we have subtracted here, so it is going to be unused now. Now out of this, we can use here I minus 6, I minus 12 already we have used, I minus 12 already we have used out of this. So how much remaining? It is going to be 6. 6 are remaining. So we can form the instruction equation like this: 2 raised to power I minus 12 minus 10 multiply how many combinations? 2 raised to the power 6 combinations, because we have 6 bits for the opcode. Clear? Now what about this one? Out of this, how many we are using? 364. So what will be the unused? This is going to be the unused. Clear? Now multiply by this. So here we have how many bits for opcode? Out of I minus 6, we have used here I minus 6, so 6 is remaining. Again we are going to have 2 raised to the power 6 here. Clear? And this is going to be 1280. This is going to be equal to 1280. Now you can solve this equation. You can solve this equation and you can let me know what should be the answer. It's completely fine, Yogesh, don't worry. You can just attend the session. You will understand most of the things. Okay, 16 bits, as many students are saying 16 bits should be the answer. You can solve this equation, that will give you the correct answer. Okay, you can do the calculation. Let's proceed to the next question now. Okay, so this is almost same type of question. If you can solve this, we can proceed to the next question. Yes guys, can you solve this question? 2 address, 1 address, it is given, instruction size is given. What is the maximum size of memory supported by the system? Maximum size of memory supported by the system. How you can find this? Now in this question you have to assume the address field. Let's suppose it is X, because it is not given in the question. Now whatever will be the value of X, 2 raised to the power, that will give you the maximum size of the memory supported by the system. I hope you can do it. Can you do it? Can we proceed to the next question now? Okay, fine. Yes guys, solve this one now. Answer this question now. Yes, solve this one. These are the most expected questions. Okay, most frequently asked questions. Yes guys, quickly solve this. So in this question, everything is not given you directly. Okay, you have to find some values. Then you can solve this. And guys, do share this session. Keep liking the session. Those who have joined just now. Yes guys, quickly. We have so many questions to cover. Still addressing modes question, cache questions are remaining. Apart from this, we also have some questions from pipelining, and other topics. Yes, anyone getting the answer for this question? Three types of instructions are there: R type, I type and M type. Okay, let's see this question. Those who are getting doubt, let's solve this question. A CPU has 128 registers, 64 KB byte addressable memory and 4 bytes instructions. Okay, 4 bytes instructions means instruction size is of 32 bits. Clear? Let's assume this is R type, let's assume it is I type and it is M type. Okay, now it is given each R type instruction contains an opcode and 2 register names. So R type we have opcode field and 2 register names are there. Okay, let's say R1 and it is R2. Clear? Each I type instruction contains an opcode and a register name and a 9-bit immediate value. So here it is going to be opcode, here it is going to be register and it is immediate value, 9-bit immediate value. Clear? Now each M type instruction contains an opcode and a memory address. Okay, so opcode is there and what else? Just the memory address. Clear? Is it clear so far? Now if there are 3072 R type instructions, 252 these I instructions, maximum how many M type instructions can be formulated or that CPU can support? 128 registers we have, that means 7 bits for this, 7 bits here, and here it is given 64 KB byte addressable memory, that means 2 raised to the power 16 bytes is the memory size. So if it is 2 raised to power 16 bytes, that means 2 raised to power 16 addresses will be there, so address size will be 16 bits. Address size will be 16 bits. Now out of this is 14, 32 minus 14, it is going to be 18. Correct? Now it is also 32, so this is 16, this is going to be 16 here, and this is also 32. 32 minus 16, it is going to be 16. So I told you, you have to start with whichever type of instruction is having less number of opcode bits. So if you see here 16 bits are there, 16 bits are there, that means you can start with either I type or M type. So if you start with, let's say, M type, so what do you get? 2 raised to the power 16 maximum opcodes. M, we have to find out maximum how many M type instruction. Let's say it is X, so 2 raised to power 16 minus X, these are unused. Now we can use it for this one. Out of 16, here you also we have 16, that means nothing is remaining, so we can say 2 raised to the power 0, which is 1 only. Now these are I type instructions. Now out of this, how many we are using? 252 I type instructions, so minus 252 will be there, minus 252 will be there, and these are unused. Now we can use this for R type. Out of 16, out of 18 we have 16 already used, so 2 are remaining, so we can have this equation into 2 raised to the power 2, that is 4, and that will be equal to how much? 3072 R type instructions. Clear? Now you can solve this equation and you can get the answer for X. You can use calculator. 64516, yes, that is correct. X value will be equal to 64516. Guys, perform the calculation carefully because these questions are not very difficult. These questions are not very difficult, but yes, if you are not performing the calculation carefully, you may commit silly mistake. Okay, so I hope it is clear. Yes, 64516 is the correct answer. Suhas, yes, your answer is absolutely correct. Okay guys, let's proceed to the next question now. Solve this question. That is a previous year question, GATE 2016. So I told you I have also included few previous year questions for you so that you can analyze your performance as well, how much you have learned so far, and are you able to solve previous year questions or not. Okay. Yes, quickly solve this and let me know what should be the correct answer. This question should hardly take one minute, I would say. After reading the question, maximum 1 minute is required. Yes, Muskan, do you have any doubts in the previous one? How did you find the remaining part? So first you have to find maximum, then subtract the already used. Okay, then you will find the unused. That you have to use for the other type of instruction. How you got 32? Okay, let's see this. 64 KB. Okay, so here I have committed mistake maybe. Okay, it is given now. It is given 4-byte instructions. So 4-byte instruction, that means the length of the instruction will be 32 bits. Harshit, is it clear? Yes, Muskan, what is your doubt? Please ask. See, first you have to start with either I or M. Why? Because both are having same number of opcode bits, right? So let's start with M. So if you start with M, 2 raised to the power 16, this is maximum opcodes. You have to assume how many M type instructions we can have. So let's assume it is X. Unused will be 2 raised to the power 16 minus X. That unused you can use for I type. So here it is 16, here it is 16, that means remaining is 0. So 2 raised to the power 0, here it is 2 raised to the power 0. Clear? That is 1 only. Now this is maximum for I type. Out of that we have used 252. Out of that we have used 252 I type instructions, right? So this is now unused because we have subtracted, so it is unused. We can use it for R type now. Out of 18, 16 is already used, only 2 is remaining, so 2 raised to power 2. These many combinations we can form, right? And that will be equal to 3072. Then you can solve this. Yes, what will be the answer? Okay, Satyam is saying 500 bytes is the correct answer. Okay, Muskan. Yes, that is absolutely correct. Very good, all of you. Let's solve this previous year question. Consider a processor with 64 registers and an instruction set of size 12. Now, what is the meaning of instruction set of size 12? Whenever it is given instruction set size, that means these many distinct type of instructions your processor can support. Clear? And that is given to you 12. So if it is 12, that means how many bits for opcode? How many bits for opcode? It is going to be 4 bits because 2 raised to power 4 is 16, 2 raised to power 3 is 8, right? Each instruction has 5 distinct fields. Opcode, 2 source register identifiers. Opcode is there, let's say R1 source register, let's say R2. What apart from that? 1 destination register identifier, let's say it is R3, right? And 12-bit immediate value. So immediate value is there, which is of 12 bits. Clear? Now 64 registers, that means 6 bits, 6 bits and 6 bits, right? Each instruction must be stored in a memory in a byte aligned fashion. That means it is byte addressable memory. If a program has 100 instructions, the amount of memory in bytes consumed by the program text is what? So what is the size of one instruction? That is 10, 16, 16 plus 18. That is going to be 34. 34 bits will be there. This is the length of one instruction. This is the length of one instruction. So overall, if you say, like if you have to represent in bytes, it is 34 bits. So 34 divided by 8, you have to take the ceil value, because the in one you can store 32, rest remaining data you have to store in the next byte. So it is going to be 5 bytes. You have to take the ceil value. So one instruction is consuming 5 bytes. 100 instructions will consume how much? 500 bytes, and that is your answer. This is the amount of memory that is required. 500 bytes is the correct answer for all of you. Yes, so now Satya sir will continue this. Okay, and then I will come back again after some time, right? So let's switch the topic and let's see if you are good enough in the other topics also. Yes, please join Satya. Yeah.
Thank you, Anshul sir. Hi students again. I hope you are enjoying the session, and I hope many of you did not have lunch also. Don't worry guys, just attend the session while eating, eat while attending, but don't miss this session because it is going to be very useful, very interesting session. So first I have updated some questions, so let me get the new PPT for you. Just give me 1 minute. We have already solved 10 questions, right? So, yep. Yep. No need lunch. No, Chandan. Just you can attend the session while having the lunch also. Don't miss any. Don't miss your lunch. Don't miss this class also. Okay. Let's do multitasking for today. Okay. So here is the next question of mine. The capacity of a memory unit is defined by the number of words multiplied by the number of bits per word. Okay. Yeah. How many separate address and data lines are needed for a memory of 4K by 16? Rahul Raj, definitely you will get. So we want how many separate address and data lines. It's clearly given 4K by 16. What does this mean? There are 4K words. Each word length is 16 bits. Right? So the data bus width should be 16 bits because one word at a time can be carried out. So at a time how many bits can be carried by the bus? 16 bit. And here 4K words indicates 2 raised to 12 words. So how many address bits are required? If there are 2 raised to I words, I bit address would be required. So 12 address lines and 16 data lines. Simple. Very good. Superb. Now next question. Yep. Consider an instruction R0 equals to R1 plus R2. The following steps are used to execute it over the data path. Assume PC is incremented appropriately. The subscripts R and W indicate read and write operations respectively. If so, what is the following? Which of the following is the correct order of execution of the above steps? So here are the options. It's a previous gate question, dear friends. Yes. Here firstly the instruction needs to be fetched. Assume that it is decoded, then we have to fetch the operands, execute, store the result back. So here we are considering all the phases of instruction cycle, assuming instruction decode is done automatically, right? So firstly, what is instruction fetch? Loading the instruction from memory to CPU. CPU means where? To the instruction register, right? But how we know from which address to load the instruction? That is known to PC. So from PC we have to copy that address to address bus, because address bus, address register and data register, these are the only registers that are a channel to communicate with memory. So from PC first you should copy the address of next instruction to be executed to address register. So where do you find that? Obviously here. So PC read and write in the address register, from that address read from memory. So definitely the third step should be upfront. So from there you can just eliminate two options, option A and option B. Now when you get the instruction from memory, will it directly come to IR? No, it will be dumping into data register, MDR. So where we are getting it? MDR. But where the instruction is supposed to be? In the IR, instruction register. So read from the data register and write in the instruction register. So the next step should be 5. Okay, then now the instruction is in the instruction register. Assume data decoding is done. Now what is the next phase? Operand fetch. Fetch the operand. Yep, see here, first operand I am fetching from register R1 and storing in the temp. Second value I am fetching from R2, storing in temp, and I am giving add command to ALU. So what should be next? 2 followed by 1, then write the result back to R0. So this should be the correct sequence, 3 5 2 1 4. Option C is correct, right? Next, consider a non-pipelined processor with a clock rate of 2.5 gigahertz and average CPI of 4. Okay, the same processor is upgraded to a pipelined processor with 5 stages. Very good. But due to internal pipeline delay, that is what the drawback of pipelining over non-pipelining, we require intermediate buffers. Due to them, the speed reduced to 2 gigahertz. Okay, assume there are no stalls in the pipeline. What is the speed up achieved? Quick, give your answer for the third question now. Quick. Already I have covered 10 questions. Anshul sir has covered 10 questions, and this is again the third question. So already you are solving almost 25 valuable questions, very efficient questions. So by this time I believe you have got some confidence for COA or some idea what kind of questions you should focus much, right? So 13th, Chandan is giving option A, okay. Keshish, option A, right. Here, for a non-pipelined processor, the frequency is given. We know frequency is inversely proportional to clock cycle time, right? Or in the other way, cycle time is inversely proportional to frequency. We know the time to execute, whether it is non-pipelined or pipelined, is cycles per instruction multiplied by cycle time. But here we are given with only frequency, so this we can also write as CPI divided by frequency, because cycle time is inversely proportional to frequency. Okay, so let me put it as CPI1 and F1. Now you please understand, in the question everything is given. For a non-pipelined processor, the CPI is 4. So this is 4 divided by, what is the frequency given? 2.5. It is maybe 40 by 25 you can write. So this is equal to 1.6, the non-pipelined time. In the same way, what would be the pipelined time? Let it be CPI 2 divided by F2. This is ideal CPI, which is 1, and what is the new frequency? 2. This is 0.5. Now we want the speed up achieved. Speed up is equal to non-pipelined time divided by pipelined time, that is 1.6 divided by 0.5, which is I think 3.2. Yep. Correct. Superb, superb. Satyam, Harshit. Yeah, this session is not that you can solve everything. The session is to let you know what are different model questions that you have to focus, or what kind of questions you should not miss. For that understanding also, right? Don't worry. Stay focused. Guys, I know it is lunchtime and you people could be hungry. I am giving you the liberty, right? You can attend this session while having the lunch. So do multitasking for today, but don't miss this session. Chalo. Next question. Consider CPU with 5 different types of control signals to generate multiple times. The total number of bits required in horizontal and vertical microprogramming. So Harshit, for this question especially I will wait for your response, because you have learned what is this horizontal and vertical microprogramming in this session. So please apply the knowledge that you have gained in this session. In horizontal, if it is I signal, I bit would be required. In vertical, log I bit would be required. Simple. Oh, De Villiers, hungry for solving questions, not for food. Quotation अच्छा है, लिख सकते हैं आप. Vikas, manufacturing defect. I am happy and I am always happy, especially when I am with you guys. भगवान ऐसा बनाया, कुछ नहीं कर सकते. Expressionless face. Yeah, some face will not have expressions. That is the complaint even from my wife also. But I am very happy here, because I am with Anshul sir and with you guys in this Maha Marathon session. We are collectively learning this subject, computer organization and architecture. Okay, so in horizontal, as I said, if it is I bits, I signals, we would require I bits. Here type 1, we have got 20, so 20 bits would be required, and type 2 10, so 10 bits would be required. Type 3 15, so 15 bits, and type 4 60, so 60 bits, and type 5 30, so 30 bits. So please do the summation. And for vertical, we do we apply log with the seal. So it is log 20 base 2 with the seal value, that is 4 bits, not 4 5. In the same way, apply log for all. Log 10 would be 4 bits with the seal. Log 15 is again 4. Log 60 would be 6 bits. Log 30 would be 5 bits. Do the summation. Here 20, 30, 45, 105, 135, and here it is 9 plus 4, 13 plus 6, 19 plus 5, 24. So it is option B, 135 bits for horizontal and 24 for vertical. Okay. Next question. Suppose an unpipelined processor with 25 nanosecond cycle time is divided into 5 stages with latencies 5, 7, 3, 6 and 4 nanoseconds respectively. If the latch latency is 1, latch latency means the intermediate register, the buffer latency is 1, what is the cycle time of the resulting processor? Wow, very easy question. Unpipelined processor is divided or turned into pipelined. Yeah, I understand you are also hungry. Anshul sir is also hungry. He is trying to have lunch without me. Okay. Yep. D. De Villiers says D. Okay, Navneet says D. Right, guys, we are having the stage delays as 5, 7, 3, 6 and 4 nanoseconds. So when you take up max of TD, this is 7 nanoseconds, and we have interstage delay latency as 1 nanosecond. So what is the cycle time of the resulting pipelined processor? Max of TD plus 1 time of interstage delay, that is latch latency. This is 7 plus 1, 8 nanoseconds. So option D, correct. Next question. If unpipelined in an unpipelined machine, assume that the times required for the 5 functional units which operate in each of the 5 cycles are so and so. Addition of buffers adds 1 nanosecond overhead. Find the speedup versus unpipelined execution. Somehow in the non-pipeline, buffers are not required because context switching is not needed. It is a serial processing. there is no need to switch from one instruction to another instruction. After finishing one instruction, then only another instruction is taken up. So their buffers are not required. So there we say buffer delay or the latch latency is 0. Okay. So here we want speed up. What is speed up? Non-pipelined time divided by pipelined time. Here to calculate the total non-pipelined time or pipelined time, we require number of instructions. As we don't have, you can even relate this with cycle time or one stage time also. So what is non-pipelined cycle time? Which is summation of all the stage delays, because it happens one after another. And what is pipelined cycle time? Just now we have solved max of all the stage delays with interstage delay. So this is summation 10 plus 8 plus 10 plus 10 plus 7, that is 18, 28, 38, 45 nanosecond. Here this is max of TD, max of this is 10 plus 1, 11 nanosecond. So this is 45 divided by speed up, 45 divided by 11, approximately it is 4.1. Very good. Very good vision, anonymous. Keshish, Chandan, Prakash, Anvesha, Patra, Saubhagya Nayak, Muskan Priya. Superb. Let's proceed to next question. If an unpipelined processor with a cycle time 25 nanoseconds is evenly divided into 5 pipeline stages, what is the total latency of the pipeline? I think some information is missing here. Even for this information also we can calculate, I think, because it's very simple. 25 nanoseconds is evenly divided into 5 stages. So 5, 5, 5, 5, 5. As the latch latency is not given, we can assume the latch latency is 0. Okay. So what is max of this latency? 5 only, plus 0 because it is not given. So the total latency, if number of instructions is given, we could have multiplied with that. As it is not given, you can say it is none only, definitely. Yes, Madhav Maheshwari, correct. Next question. A non-pipeline system takes 50 nanoseconds to process a task. The same task can be processed in a 6-segment pipeline with a clock of 10 nanoseconds. Determine the speed up of the pipeline for 100 tasks. What is the maximum speed up that can be achieved. Shubham, still if you take only one instruction, then it could be 25 nanoseconds. But generally, when there is only one instruction, pipelining is not preferred, right? So, if you take multiple instructions, then it would be definitely in the pipelined manner it goes on. Then we have to know number of instructions. As you calculate stage wise or cycle time, it would be 5 only. Okay. Firstly, what is the maximum speed up that we can achieve? The maximum speed up is always less than or equal to number of stages. It is known the number of stages is 6 stages or segments. So definitely the maximum speed up would be less than or equal to 6. As you see, you can have 5 or 4.76, anything, fine. Now we want speed up, which is non-pipelined time divided by pipelined time. What is non-pipelined time? Number of instructions multiplied by number of stages multiplied by cycle time. And what is pipelined time? It is n minus 1 plus k whole multiplied by t. This is non-pipelined, this is pipelined. Cycle time. Number of instructions given as 100 and number of stages 6 and non-pipelined cycle time 50 nanoseconds. Wait. Here it is directly given for one task to perform, it takes 50 nanoseconds. For 100 tasks to perform, so directly you can say actually it as 50 into 100 divided by 6. 100 minus 1 plus k is what? 6 multiplied by, and here we have got 10. So this is nothing but 5000 multiplied by 1050. You will get what is the speed up? 4.76. Okay, yeah, De Villiers. Next, an instruction pipeline has 5 stages where each stage takes 2 nanoseconds and all instructions use all the 5 stages. Okay. Branch instructions are not overlapped. Yes, of course, known. The instructions after the branch is not fetched till branch instruction is completed. Once the branch instruction is taken, till it gets completed, the other instruction is not fetched. Okay. Calculate the average instruction execution time assuming 20% of the instructions are branch. Ignore the fact that some branch instructions may be conditional. Okay. Unnati, for calculating the pipelined time, that k value or that 6 value is required. Yes. So I want the average instruction execution time. What is the formula with respect to stalls? 1 plus stalls frequency and how many cycles the stalls stay back, and what is the cycle time. It is given 20% of the branch instructions, and when branch is fetched, it gets stalled. From the question we can understand that. Multiplied by how long the stall preserves. If you look at the question, read, understand, after the branch is once the branch is taken, till that branch instruction gets completed, no other happens, right? So once the branch instruction is fetched, what are the next, how many cycles we have further? It is given 5 stages. So after fetch we have 4 more stages. Let them be decode, operand fetch, execution, write back or memory. So once the fetch is done, the next 4 would be stalls. So the number of cycles the stall preserve, you can say, is 4. And what is the cycle time? 2 nanoseconds. So this is 80 by 100, 0.8. So this would be 1.8 multiplied by 2. So this would be 3.6 nanoseconds. Nano or milli? Nanoseconds. Because it is given in the nanoseconds. Yep. Good. De Villiers, Navneet, Muskan, Chandan, Anvesha Patra. Very good. Yes, keep giving your responses, and also keep sharing the session, guys. Next. So this is pretty popular model, most frequently occurring model, and very easy model also. Please read the question. A 5-stage processor has instruction fetch, instruction decode, operand fetch, perform operand, and write operand stages. IF, ID, OF and WO take 1 clock cycle each for any instruction. PO stage takes 1 clock cycle for add and sub, 3 clock cycles for mul, and 6 clock cycles for div instruction. Okay. Operand forwarding is used in the pipeline. Means the data dependency, the read after write dependency can be ignored because operand forwarding will take care of that. What is the number of clock cycles needed to execute the following sequence of instructions? Options we have 13, 15, 17 and 19. First, from the given question, it is better if you can form table kind. I naught here, let me write here, we are having 4 instructions, I0, I1, I2, I3, and we are having 5 stages named IF, ID, OF, PO and WO. I0 is mull instruction. It takes 1 cycle for IF, ID, OF and WO, but for PO it takes 3 cycles. I1 is div. It takes 6 cycles for PO, for the other it takes 1. And for I2, I3 are add and sub, so they take 1 clock cycle for all the stages. So now you got the information in more clear form. Now draw the state space diagram, space time chart. Then we can easily get this. So I0, IF require 1 clock cycle, ID require 1 clock cycle, OF require 1 clock cycle, PO require 3 clock cycles and WO require 1 clock cycle. I1, IF1, ID1, OF1, PO we cannot perform because another PO is happening. PO requires 6 clock cycles and then WO. I2, IF, ID, OF and all this way we cannot perform PO and then WO. And finally I3, IF, ID, OF. So here you will perform PO and then WO. Now count total how many clock cycles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. Excuse me. No. So total 15 clock cycles would be required if you execute using pipeline. Okay, next question. It's a previous gate question, good question in fact. Go through the question carefully. The pipeline has IF, ID, OF, PO and WB stages. IF, ID, OF, WB take 2 clock cycles each for every instruction. Now consider a sequence of 100 instructions. In the PO stage, 40 take 3 clock cycles, 35 take 2 clock cycles and remaining 25 take 1 clock cycle. Assume there are no data hazards, no control hazards. Okay. Then the number of cycles required for completing the execution of 100 instructions. Here, what are the phases? Firstly, we have IF, ID, OF, EX and WB. They take 2 clock cycles for any kind of instruction. Here we have 40 instructions, that is one set. And then 35 one set and remaining 25 one set. So for any instruction they are taking 2 clock cycles, but EX, it's not EX, it is PO. Acha, okay. But PO is taking 40 instructions 3 clock cycles, 35 2 clock cycles, and remaining 1 clock cycle. Now for the 40 instructions, first let us calculate what is the total time in the pipelining, then for 35, then for 25. Okay, first for 40 instructions, what is the T maximum of TD? As a TI nowhere it is given, so it is maximum of 2, 2, 2, 3, 2. This is nothing but 3. So now what is T? N plus K minus 1 whole into small t. Number of instructions 40, number of stages 5 whole into 3. This is 44 into 3, 132. Now next 35 instructions. What is T? It is maximum of all 2, which is nothing but 2. So what is the time for these 35 instructions? 40 plus 5 minus 1 whole into t. This is 44 into 2, 88. Then for remaining 25 instructions, it is max of 2. This is again 2. This would be now, wait. Here I have taken 40. It's not 40, right? 35 only. So this is 39 into 2, 78 nanoseconds only. Okay, T3, now 25 instructions with 5 stages, and the stage time is now 2. So this is 30 minus 1, 29 into 2, 58. So altogether it is becoming 132 plus 8, 140, 70, 210 plus 58. So total time T1 plus T2 plus T3, 268 nanoseconds. Yeah, Muskan, I have corrected it. It's not 40, only 35 instructions. Okay. Next, 168. We don't have that option. Strange. So there could be some calculation mistake. Check it. 40 take 3 clock cycle, 35 take 2 clock cycle, remaining 25 take 1 clock cycle. These all taking 2 clock cycle. So here max is 3, max is 2, max is 2. So perfect. 40, number of stages 5. 44 into 3, 132. Here 35 plus 5, 40 minus 1, 39 into 2, 72, 78 only. Where we have gone wrong? I think it should be 268, not 168. Might be some typo. It should be 268 because definitely this is the time for 40, 35 and 25. So 132 plus 78 is 210 plus 58, 268. Definitely 268. It could be typo. Yep, don't worry. Yep. Next question. The stage delays in 4-stage pipeline are so and so 800, 500, 400 and 300 picoseconds. The first stage, which is the 800 picosecond stage, that is replaced with a functionally equivalent design involving 2 stages with respective delays 600 and 350. What is the throughput increase? Okay. For the old design, what is the cycle time? Max of this. What is max of 800, 500, 400 and 300? $800, right? Okay. Now that 800 design is replaced by 2 stages. The 800 stage is replaced by 2 stages. Now what are the stage delays? 600, 350, 500, 400 and 300. Now what is the maximum? 600. Now it's a simple aptitude. One is doing work in 800 nanosecond time, other is doing work in 600 nanosecond time. So what is the increase in the performance? It's a kind of simple calculation. So it is 800 minus 600 by 600. Maybe it is 100 by 300, 1 by 3, 33.33%. Okay, yeah. Chandan, you are correct, very good. Anonymous, Noob Studios, Saubhagya, Kirti Kumar, Navneet Kaur, Madhav Maheshwari. Good, very good. Good guys, keep it up and do like the session, do share it in your student community through WhatsApp, Telegram, Facebook, Insta, everywhere. Next question. Okay. Let me make it MSQ, guys. No, let me make it MSQ. If the data stored inside secondary memory is identified and accessed with its sector address CHS, then which of the following is valid representation for it? Noob Studios, I think you are our paid student. Not all the questions. There are some questions which are not done. Maybe the model could be same, but it is good that you are able to do them again, practice them again. So what is the valid representation for CHS? Default C means what? Cylinder number. H means head number. and S means sector number. This is the default. That's how you got CHS. But we know cylinder number is also equal to track number, and head number will always be equal to surface number. So cylinder number, head number, sector number, yes, this is valid. Cylinder number, head number, surface number, no. Head number, surface number, both are same. It should be sector number. Track number, yes, cylinder number, track number would be same. Surface number, sector number, correct. And cylinder number, surface number, sector number, this is what the default. So if it is MSQ, when you select A, C, D, all the three, then only the mark will be awarded, otherwise none. Means otherwise you will not get any mark. Partial award will not be there for MSQs. You should select all complete answers, all correct answers. Okay. Next question. We have some hard disk specifications. Just I want how many bits required to address the sector. Sambhav Jain. Oh, good. Vikas, what actually you wanted to ask? This is COA marathon only. Gate architecture. So have you included any new subject called gate architecture? We are covering both organization topics as well as architecture topics in this marathon, right? Anshul sir is covering machine instructions, addressing modes and cache memory related questions, and here I have made you to solve secondary memory, ALU design, CU design, IO interfacing, and also this pipelining questions. That is what the syllabus, right, we have. If you are not sure, please refer our gate syllabus once. So Sambhav Jain says 25. Yep. Here you please focus. Mostly, if you have read this question partially, most of the students would be doing this. There are 16 platters. Every platter has 1024 cylinders. Every cylinder is having 128 sectors. Right? This is 2 raised to 4, 2 raised to 10, 2 raised to 7, that is 2 raised to 21. So 21 bits. We don't have. If you do multiplied by 512, because there are 512 bytes per sector, you would be doing into 2 power 9, that is 2 power 30, so 30 bits. That is also not there. So just by looking hard disk specifications, number of bits required to address, if you just go ahead with the old procedure, definitely you will mess. When you read the question, you should read it carefully, completely. See, suppose the secondary memory is word addressable instead of sector addressable. Generally, secondary memory would be sector addressable. But this question is asking us to assume if it is word addressable and one word is equal to 32 bytes, then what is the, I think we cannot erase all together at once, right? Like how we do So now see, firstly there are 16 platters. Every platter is having 1024 cylinders, 128 sectors, and every sector is having 512 bytes. One sector is having 512 bytes. That means how many words? 512 divided by 32. This is 16 words. So this is 2 power 4 into 2 power 10 into 2 power 7 into 2 power 4, 2 raised to 28. Isn't it? Sorry, Saubhagya 26. Right. 14 plus 7, 21, 11, 10, 21, 4, 25. But this is wrong. Why? Because 16 platters given. We know every platter will have 2 recording surfaces. So that is default, guys. It need not to be given. So you should multiply with 2 because every surface contribute for the cylinder, and there are 1024 cylinders, 512, 128 tracks, 128 sectors. Every sector is having 16 words. So this would be 2 raised to 4 into 2 into 2 raised to 10, 7 and 4. This would be 2 raised to 26. So 26 bits. So if you solve it without multiplying with 2, only taking platters into account, you will get to 2 power 25 or 25 bits, and that is also in the options, and you would think it as correct, but it is not correct. So be careful. Okay. Yes, after this again Anshul sir will join, and he is ready with some more important questions. Right, Madhav? That's why you have to be very careful. Somehow we shouldn't add 512, we shouldn't multiply 512, because we don't give address for every byte, we give address for only sector. 512 bytes together will have one address in by default. Okay, please solve it quickly. We have some specifications for the hard disk, and now sector number is given. What is the CHS for it? As it is MCQ, simple, and as you will have virtual calculator in the gate, one simple way is do reverse engineering. As you already have the formula, apply formula on each option. Which option gives you this number? That is the answer. Because you are having virtual calculator, but that is not the standard method. So how you get the standard value? I mean, in the standard way, how you get the CHS? quickly I will explain. Please listen carefully. We are having the sector number 18324. That means which sector will have this number? 18325th sector will have this number 18324, because the numbering starts with 0. When you take the count, this would be 18325th sector, right? Now we know for a cylinder, every surface contribute one track sectors. So one cylinder means how many surfaces we have? 32 surfaces. Every surface will contribute one track. One track means 128 sectors. So 2 raised to 5 into 2 raised to 7, 2 raised to 12, that is 4096 sectors contributed for one cylinder. Now we have 18325 sectors. So for this, how many cylinders would be required? 18325 divided by 4096. Use calculator, everybody. I am also using along with you. So 18325 divided by 4096, that is 4.47. That means even 4 cylinders are also not sufficient. You require 5 cylinders. But we know numbering will always starts with 0. So what would be C value? As you start with 0, for 5 cylinders, if you give numbering 0, 1, 2, 3, where it ends? At 4. So C value is 4. Okay. So you can just take option C out. Now we want H. Here 5 cylinders you would be required. Which cylinder is occupied partially? Only the last cylinder. Means first 4 cylinders occupied completely, right? So with on 0, 1, 2, 3 cylinders, how many sectors are occupied? 4 multiplied by 4096 sectors you have accommodated. So what is this value? This is 2 raised to 12 into 2 raised to 2, 2 raised to 14. So 16,384 approx, I think. Yeah. So 16,384, better let me not take chance. Yeah, 16,384 sectors are there on 0 cylinder, 1 cylinder, 2 cylinder and 3 cylinder. We have 18,325. So for cylinder number 4, that means 5th cylinder, how many sectors remained? 18,325 minus 16,384. Use your calculator, which is 1941 I got. So these many sectors are there on cylinder number 4. Now one surface contribute how many sectors? One surface will contribute only one track sectors for a cylinder, that is 128 sectors for a cylinder. So for 1941 sectors, how many surfaces require? 1941 divided by 128. It's a big procedure. That's why I am telling, just apply reverse engineering, apply the formula on every option. Which option gives you this 18324? That is the answer. Because the standard procedure is very lengthy. So 1941 divided by 128, this is giving 15.16. That means even 15 surfaces are not sufficient. 16 surfaces would be required. But as you number surfaces or any from 0, here H would be 15. So on 15th surface number 15, this particular sector ends. So H is 15, C is 4 we got. So 4, 15, okay. So you can't take any option out. Definitely you have to calculate yes value. Now again, just step back and you see 15 surfaces completely occupied. So on 15 surfaces, how many sectors you can accommodate? 15 multiplied by 128, that is 1920 sectors. So for the last surface, that is surface number 15, how many are remaining? Remaining would be 1941 minus 1920, 21 sectors remained. So you do numbering from 0. What would be 21st sector number? 20. So what would be CHS? 4, 15, 20. This is how you derive. But to do this, minimum 5 minutes time would be required. You could do 3 questions in that time, 3 other questions. So guys, don't be overexcited to apply always standard methodology, because it's a competitive exam. Time management you should practice. It is understand that you are perfect in the procedure, but based on the time you have to go with shortcut method or the standard method. Okay, so here the answer is 4, 15, 20. But if it is the MCQ, please do reverse engineering, apply the formula on every option and go with the solution, go with the answer. Okay, so these are what questions. Now Anshul sir will join. Yeah, Anshul sir will join and he will make you practice some more questions. Okay, see you after some time, guys.
Thank you, sir. Yeah. Yes, guys. So finally, I'm back, and now you need break, Chandan. Okay. Just give me a minute. Okay, so let's start. This is the next question. That is a GATE previous year question, GATE 2018. So I hope, guys, you can solve this question easily. Yes, thank you, Rahul. Yes, guys, read the question carefully and quickly solve it. Let me know what should be the answer. 2 minutes break. Yes, no break, guys. So we have approximately 18-20 questions left. Let's complete it and then we can just we will try to complete as soon as possible. Okay, yes, I'm done with my lunch. Quickly solve this. Let's read the question. A processor has 16 integer registers R0 to R15 and 64 floating point registers F0 to F63. Okay, it uses a 2-byte instruction format. There are 4 categories of instructions: type 1, type 2, type 3 and type 4. Type 1 category instructions of 4 instructions. So basically type 1 we have 4 instructions, each with 3 integer register operands. Okay, let's solve this question. Let's say this is a type 1, this is type 2, type 3, and we have type 4 as well, right? Yeah, type 4. Okay, so here you can see in type 1 we have each with 3 integer operands. Okay, so we have the opcode and we have 3 integer operands. Let's name them I1, I2 and I3. Fine. And it uses a 2-byte instruction format. That means the length of the instruction will be what? It is going to be 16 bits. It is going to be 16 bits. In type 2, what do we have? We have 8 instructions, each with 2 floating point register operands. Okay, so here this is your opcode and we have 2 floating point register operands. Let's name F1 and F2. Fine. Now in type 3 we have 14 instructions, each with 1 integer register operand and 1 floating point. Okay, so here this is the opcode and here we have 1 integer and 1 floating point. In type 4 we have n instructions, each with a floating point register operand 1. Okay, so this is the opcode and we have just 1 floating point. 16 integer operands are there, so we can 16 integer registers are there, so 4 bits 4 bits 4 bits. It is going to be 12. 16 minus 12, it is going to be 4. We have 64 floating point registers, so 6 bits and 6 bits. 6 plus 6, 12. 16 minus 12, it is going to be 4. Here we have, this is 4, this is 6, 10, and it is going to be 6. Here we have 6, this is 10. Is it clear so far? Is it clear so far? Yes. So now we have to find the maximum value of n. We have to find the maximum value of n here. So the same concept we have to apply. As you can see, this is having less number of opcode bits, so you can either start with T1 or you can start with T2. Clear? So if we start with the T1, so how many instructions we have? So maximum opcodes will be, for T1 maximum opcodes will be 16, 2 raised to the power 4, that is 16. Out of that, how many we are using? So we can see here for type 1 category we have 4 instructions, right? That means we are using 4. Out of that, unused will be 12. Now this 12 we are using here, so 12 multiply, if you see here, 4 we have used here, 4 here we have, remaining is 0, so 2 raised to the power 0, it is going to be 1. So 2 raised to the power 0, it is going to be 1. And out of that, how many we are using for type 2? We are using 8 instructions, right? We are using 8 instructions. So it is going to be minus 8. This is going to be unused now. Clear? This is going to be unused. You can solve this. 2 raised to the power 0 is 1. 12 minus 8, it is 4. Now this 4 we can use for type 3 now. So out for type 3, here 4 we have used, remaining is 2. Right? Remaining is 2. So we can write here 4 multiply 2 raised to the power 2. These many combinations we can form. Correct? Is it clear? Now minus type 3, how many? 14 instructions we have for type 3. So out of these we are using 14. So this is 2 to 4, 16 minus 4, it is going to be 2. Now for this we can form the combination for T4. So here the maximum number of instructions for type 4 we are using is n. So here we can have this 2 multiply, and here 6 we have used. So out of 10, 4 is remaining. Out of 10, 4 is remaining. So here we can have 2 raised to the power 4, and that is equal to n. So what will be the value of n? N is going to be 2 raised to the power 5, and that is 32. This is the final answer. Is it clear, everyone? Yes, if you have any doubt, please ask. So this is a GATE 2018 question. Now you can see whatever questions we have solved so far, we can solve the same question with that concept only. Let's proceed to the next question now. GATE 2020 question. I hope you can solve this. I hope you can solve this. Yes, Saubhagya. Instruction length is 16. It is given in the question. it is given in the question. Okay, in the question it is given that it is a 2-byte instruction. So 2 byte means 2 into 8, that is 16 bits. Length, instruction length is 16 bits. Yes guys, quickly solve this. And then after that we are going to start the questions from addressing modes. This is the last question. Then we will be starting questions from addressing modes. Quickly, what should be the answer for this GATE 2020 previous year question? Yeah, Vikas, we are not going to make it private, don't worry. Okay. Yes, what will be the answer? And guys, keep sharing. Those who have joined just now, like the session and share with your friends. It is very simple question. Let's read it. A processor has 64 registers, uses 16-bit instruction format. It has 2 types of instructions, I-type and R-type. Each I-type instruction contains an opcode register name and 4-bit immediate value. Each R-type instruction contains an opcode and 2 register names. If there are 8 distinct type opcodes, then maximum number of distinct R-type opcodes will be what? Okay, Madhav is saying 14 should be the answer. Chandan is saying 14. Anyone else getting the answer? Yes guys, let's solve this question now. So this is the instruction format. Let's say this is for R type and let's say this is for I type. So here in R type we have the opcode, and what else we have? We have an opcode and 2 register names. So let's say it is R1 and here it is R2. So 16-bit instruction format it is there, right? 16-bit instruction format it is there. Clear? 64 registers we have, that means 6 bits are required for this. This is 12, 16 minus 12, it is going to be 4. What about I type? In I type we have the opcode. What else? We have the register name and we have the immediate value, that is of 4-bit. Here it is 6, 16 minus 10, it is going to be 6. Which one is less? This one. So let's start with R only. Let's assume the maximum number of distinct R type instruction is X, because that we have to find out. So 2 raised to the power 4, maximum opcodes will be what? 16. 16 minus X, that is the unused. Out of 6, 4 is used, 2 bits are remaining. So that is going to be 2 raised to the power 2. And this is equal to what? 8 distinct I type opcodes. So if you solve this, this is going to be 2, X is 16 minus 2, that is going to be 14. 14 is the correct answer. Is it clear? Yes guys, very good all of you, those who have answered this question correctly. Let's proceed to the next question now. Yes, the first question from addressing modes. Yes guys, what should be the answer? Read the question carefully and then let me know what should be the answer. This is MCQ. I will make it MSQ also. But first answer this one. What is the answer? Okay, Satyam is saying D, De Villiers D, Sambhav D. The addressing mode that permits relocation without any change whatsoever in the code is indirect? No, for indirect you have to change the instruction, right? You have to make the changes in the code as well. So that is incorrect. Immediate addressing, that is also incorrect. Indexing also, you have to change the value of the index register, that is also incorrect. PC, this is the correct answer. If it is MSQ, this is the correct. Now if I add one more option here, base register addressing. Base register addressing, let's say E option is also there. Okay, now if I say this is MSQ question, then the correct answer will be both D and E. In base register addressing mode also, you don't have to change the code. Okay, and in PC relative addressing mode also you don't have to change, you don't have to make any changes. Is it clear? Do you have any doubt here? Okay, so I hope it is clear. Let's proceed to the next question now. Yes guys, quickly answer this. These are very simple questions. You can answer these questions within 30 seconds. I'm telling you this. And mostly from addressing modes you will be getting MSQ or MCQ type of questions. There are very less chances that you will be getting numerical answer type questions from addressing modes part. Okay. Mostly you will be getting a numerical answer type question from pipelining, cache. Relocating means, Unnati, that you are shifting the code, right? If you are shifting the entire set of instructions from one location to another, that is relocating. So for that you don't have to change the you don't have to make the changes in the code. That is, it is saying in the question. Let's read the question. The addressing modes used for source operand in the following instructions are respectively. The first one, we are directly inserting the value of 5 into R, and that is what? That is nothing but immediate, right? That is nothing but immediate, because directly we are storing the constants. What about this one? First you have to go to this location in the memory, and then whatever content is present, that you are shifting into R1, and that is what? That is direct addressing mode. That is direct addressing mode. What about this one? Whatever is the content in R2, that means some value is there, so for that value you have to consider that as a memory address, and then whatever is present at that memory address you are shifting into R1. So this is what? This is register indirect. This is register indirect. Option C is the correct answer. Immediate, direct and register indirect. Is it clear? Any doubt, anyone? Let's proceed to the next question now. Yes guys, solve this question and let me know what should be the answer. And guys, those who are attending this session from the beginning, that means from 1:30 onwards, I really appreciate your efforts, because you are so consistent, right? From 1:30 and still you are going on. So that is what required to achieve a rank, a great rank in GATE, right? If you are dedicated enough towards your goal, then no matter what, if you have something else also to do, you will always focus on your goals only. No one can distract you. Yes guys, what should be the answer for this question? Read the question carefully, and let me know what should be the final answer. AB de Villiers is saying 924 should be the answer. Okay, we'll see. Sambhav is saying okay, 774 plus 150. Yes, anyone else getting the answer? Let's solve this question now. Consider a PC relative addressing mode type branch instruction which takes branch on address 770 in memory. So that means if this is your memory, here suppose you have one branch instruction, let's say at address X. Okay, so if you are taking branch, you are moving to some address in the memory, that is 770 on taking the branch. Now the instruction has offset value 150. Okay, offset value is given to you, that is 150. What is the address of this instruction in memory if each instruction is stored in memory on 4 locations? Now we have to find the address of the instruction X, okay, which is present at this address X in the memory. Okay, and it is also given each instruction is taking 4 locations in the memory. That means if this first instruction, let's say I, if it is present at X address, the next instruction, let's say I plus 1, will be present at X plus 4. Yes or no? Because four memory locations it is consuming: X, X plus 1, X plus 2, X plus 3. And then at X plus 4 you will be having I plus 1 instruction. Now as it is using PC relative addressing mode, so we know how to calculate the effective address. We know effective address is equal to what? It is equal to the PC value plus the offset. Correct? Effective address is equal to PC value plus the offset. Now here effective address, that is already given to you because that is 770. So it is 770 is equal to, what is the PC value? When I'm executing I instruction, then in PC I will be having X plus 4. Correct? Then in PC I will be having X plus 4. So here it is, because PC stores, you know what PC stores, right? The address of the next instruction to be executed, that is stored by PC. What is offset? Offset is also given to you, that is 150. That is 150. Right now if you solve the value, if you solve it, you will be getting the value X as 770 minus 154, and that will give you 616 as the answer. Is it clear so far? If you have any doubt, is it clear, Sobhagya? Okay, so read the question carefully, then only you will be able to answer the question correctly. Okay, let's see the next one now. And this is a GATE previous year question, guys. Answer this question. Remaining questions. I don't think exam will be they will cancel the exam. I don't think so. Maybe they may postpone it, but that is also very less probable. So don't think if they are going to postpone it, still you will be getting more time to solve some more questions, attempt some more test, or you can do more revision, right? But that is very less probable. I don't think so it is going to get postponed. Okay, yes, what will be the answer for this question, guys? See, here it is given during the execution cycle of the instruction. Now if you have solved it already, that is good. If I say instead of this execution cycle, if I say instruction cycle, then also tell me what will be the answer. If I say instruction cycle, then also let me know what will be the answer. Now let's see this. Those who are not getting the answer, let's understand this. Consider 3-word machine instruction. Add instruction is given to you, A of R0 comma at B. The first operand, a destination A of R0, uses indexed addressing mode with R0 as the index register. So that means first operand is using index addressing mode, second operand is using indirect addressing mode. Okay, first one is using that index addressing mode, second one is using indirect addressing mode. Now A and B are the memory addresses residing at the second and the third words respectively. So here you can consider this instruction format. You have the opcode that is going to tell you whether it is addition or multiplication. Correct? Then after that if you see, you are going to have the mode bits, mode 1, mode 2. Yes, we can represent more than one modes as well for every operand. So mode 1 is going to be for the first operand, and that is this you can write first operand, let's say operand 1, and for second it is operand 2. So mode 1 is for this one, mode 2 is for this one. Correct? Now the first word of the instruction specifies the opcode, the index register designation and the source and destination address modes during execution of add instruction. The two operands are added and stored in the destination. That means we have to perform the addition. You have to perform the addition between the data of this and this one, and then you have to store the result also here at this address. Okay, so this first operand is using indirect index addressing mode. So you know what is index addressing mode. R0 is your index register. It is having some value. Okay, now for this first operand, whatever is the index register value, you have to add with the offset, and then you will be getting what? The final address. Okay, the final effective address you will be getting. For that effective address, from that effective address you can go to the memory and you can fetch the operand. Is it clear? Is it clear so far, everyone? Okay, so R0 is your index register. You have to add the offset to this index register. You will be getting effective address. That effective address we are going to use to get the content from the memory. What about indirect? In indirect, what we do? We have at b. That means here first using this we can find the address of the effective address, because in indirect addressing mode 2 memory access are required. So first we will be accessing what? First we will be accessing the address where effective address is present. Then we will go to that point, and from effective address we can reach to the certain operand, that the value, final value that we need for the addition purpose. So two memory cycles are required for this one, for indirect addressing mode. 1 memory cycle is required for this one. So 2 plus 1, that is 3. 3 memory cycles are required, and then after the addition you have to store the result back to this operand, which is using indexed addressing mode. Again 1 more cycle is required. So 2 plus 1 plus 1. How many memory cycles are required? 4 memory cycles are required if we are talking about execution cycle. See, we have instruction cycle. In instruction cycle we have fetch cycle, in which we fetch the instruction, and the remaining stages they comes under execution cycle. So for execution cycle you need 4 memory cycles. If you talk about instruction cycle here, then you have to consider instruction fetch also. In that case answer would be 5, because you are going to fetch the instruction from the memory. So in that case answer is going to be 5, but here if it is asking about execution cycle, answer is 4 here. 4 memory cycles are required. Is it clear to all of you? If you have any doubt, please ask. Okay, so guys, we have the time till 5, so I'm going to complete the questions as much as I can very quickly. Okay, quickly answer this one. The remaining questions you will be getting the PDF, and you can solve it later on also. If we you know, within this 15-20 minutes, if we are not able to solve the remaining questions, then you can download the PDF from the Telegram group. I will share my set of questions in the Telegram group, and there you can from there you can solve the questions. Okay, yes Satyam, it is given. Where it is? Okay, it is having 3 words. Yes, that is correct. That is correct, Satyam. So 3 words. Instruction is taking 3 words. That means if it is memory word addressable, 3 words will be there. That means 3 memory locations we have to access for instruction fetch. So that is going to be but it fetch, you know, at a single time. You don't have to fetch one by one. Okay, all those 3 memory locations it is going to fetch at once. That is why it is 1 only, 1 memory cycle. Yes, quickly answer this. We count memory cycle when we are doing it one by one, when we are fetching the complete instruction at once. So no need to count it more than 1. Yes, okay, many students are getting the answer. Let's see. A CPU runs on 5 megahertz clock rate and is executing program which consists 1000 instructions. If the measured average CPI cycles per instruction for the program is 6, then total time required to run the program on CPU is dash microseconds. So here if you see, for one instruction, it is given to you, for one instruction the CPI is given to you, average CPI. So average CPI average, we can find the time required to execute one instruction, and then we can find for 1000 instructions. So for one instruction, CPI average into clock cycle time, and it is given, clock rate is given to us, so we can also write like this: CPI average divided by clock rate, because we know both are inversely proportional, clock cycle time and clock rate, correct? So we can solve this: 6 divided by 500, and it is going to be megahertz, so we can write 10 raised to the power 6. Clear? So this is the time required to execute one instruction. What about this 1000 instructions? So we can write 1000 multiply 6 divided by 500, and this 10 raised to the power 6 we can take in the numerator and it will become microseconds, so we can directly write microseconds. You can solve this and you will be getting 12 microseconds as the answer. 12 microseconds as the answer. Clear? Yes, 12 is the correct answer. Very good, all of you, those who have answered this question correctly. Quickly solve this and let me know what should be the answer. 51 हो गया. Okay. Yes guys, what should be the answer?
2n or 2 power?
2n. So this question is directly formula based. If you know the formula, you can easily solve the question. So we will be completing 2 more questions after this, and the remaining questions, 8 to 10 questions we have more, and you can, yes, you can solve them later. Okay, we will be sharing the PDF in the respective Telegram groups. You can download them and then you can later solve them, and if you get any doubt you can ask in the Telegram groups. Definitely we will reply. Okay. Yes guys, quickly solve this question. Those who have joined just now, do like the session and share with your friends. Anyone getting the answer? Question number 43. 12 is the answer for the previous question. Okay, let's solve this. A CPU is a CPU is used for executing n instructions. For executing these n instructions, CPU has taken 6 cycles per instruction on an average. That means CPI is given to you. The CPU operates on 2 gigahertz clock rate. The CPU takes total of 0.75 microseconds to execute these n instructions. So total time is given to you, correct? Now later, the same CPU used for executing 2n instructions, 2n number of instructions, and for executing this, its CPI has been reduced to 5. Total time required by CPU to execute these 2n instructions will be what? You have to answer correct up to 2 decimal places. So let's solve this. Some students are getting the correct answer. Very good, all of you. Let's solve this. For n instructions, we can say n multiply. We know total time, let's say T1. So n multiply the CPI is 6, multiply, and it is clock rate is given to you, so we can write 0.5 nanosecond. We can write 0.5 nanosecond also. We can convert this into clock cycle time. Now what about T2? T2 is having 2n instructions, right? And the CPI reduced to 5, and the clock rate is going to be same, so it is 0.5 nanoseconds. We can divide this will cancel out, right? N with n cancel out. T1 value is given to us, that is 0.75, correct? So it is going to be 0.75 divided by T2 is equal to, this is going to be 6 divided by 10, right? Now you can solve the value for T2. So you will be getting 0.75 into 10 divided by 6, correct? If you solve this, so this is 5 by 4, and the value of T2 will be 1.25 microseconds. Yes, microseconds. So 1.25 is the correct answer for this question. Very good, all of you, those who are getting the correct answer. Quickly answer this GATE 2017 question. Yes, guys. What will be the answer for this one? Question number 44. I hope after attending this session, you will be getting the confidence that yes, we can score well in this subject also. Read the question carefully and quickly answer this. Anyone getting the answer? Okay, let's solve this question. Consider a RISC machine where each instruction is exactly 4 bytes long. Conditional and unconditional branch instructions uses PC relative addressing mode with offset specified in bytes to the target location of the branch instruction. Further, the offset is always within respect to the address of the next instruction in the program sequence. Consider the following instruction sequence. If the target of the branch instruction is I, that means this one. This is the branch instruction we have, right? So this is the condition we have. If it is true, then we have to make the jump here. Then the decimal value of the offset we have to find out. As it is using PC relative addressing mode, so here every instruction is 4 bytes long. That means if I say this is present at address 100, next instruction would be present at 104, this one 108, this is 112. And let's say if we are executing this branch instruction at this point of time, PC value will be 116, yes or no? Because it will point to the next instruction to be executed. The decision of taking branch will be taken later, right? But at this point of time when it is executing, PC value will be 116. Now if I'm present at, if PC value is this one, so how to calculate the effective address? That is going to be PC plus offset, right? Effective address is 100 because we have to move to this one, so 100 is equal to PC value is 116, offset we have to find out, so offset value will be 100 minus 116, that is going to be minus 16. This is the answer. Minus 16 is the final answer. Very good, all of you, those who are answering this correctly. Okay, let's proceed to the last question. Yes guys, quickly solve this. Remaining questions you can solve later on. It's 4:59. This is the last question of today's class. Yes, what will be the answer? Let's read the question. A DRAM chip of 512K by 8 bits has 256 rows of cells with 2K cells in each row. If DRAM takes 20 nanosecond for one refresh, then total refresh time of the DRAM is dash microseconds. Now here, to understand this question, you need one concept to understand, that if DRAM takes 20 nanosecond for one refresh, that means if using this time, in this time it is refreshing one row of the DRAM. Now we want to find out the total refresh time of the DRAM. That means to refresh the entire, all the rows of the DRAM, how much time it will take. So for one row it is taking 20 nanosecond. How many rows we have? It is given 256 rows of cells. So we can say 256 multiplied by 20 nanosecond. And we have to answer in microseconds. So first you calculate this. So it is going to be 5120 nanosecond. If you compute this in microsecond, divide by 1000. So 5.12 microseconds is the answer. No De Villiers, that is incorrect. 5.12, yeah, Satyam, that is correct. Okay, so guys, that's it from our side. Due to the time constraint, we try to cover as many questions as possible. Right now we will be winding up this session because
Yes guys, I really appreciate everyone's patience and for the long stay. Some people are here even without having their lunch. I really appreciate them. Definitely your hard work pays off. Guys, though we are concluding here, there will be more questions in the PDF. So you can take them as your self-practice, and if you have any doubts in that, you can just post in our respective Telegram groups. We will be definitely happy to assist. And however, our Telegram groups now became like a student community, because they're all students who are preparing for the same exam are there. So mostly your friends only will clear your doubts. However, if your doubt is not yet resolved, definitely we will be happy to solve that doubt. Fine, no problem. So here we are winding up. Okay, and we will post the complete PDF in the Telegram group. And from today, it is just beginning, guys. From today for 15 days these marathon sessions happen every day at 1:30 p.m. So please set the time, that is 1:30 p.m. and try to inform your friends about this Maha Marathon session, and try to bring your friends also for this. So keep attending these sessions, keep learning, keep growing. All the very best. See you in the next session. Tomorrow I would be taking the Maha Marathon session on programming and data structures. Okay, thank you all. See you tomorrow at same time 1:30 p.m. Okay, thank you, bye bye.
yeah, thank you all. So all the best, keep preparing. You have less days now, so keep preparing, keep revising, and do attend all these sessions, because that is going to be giving you a lot of benefit. Okay, no PDF, password will not be there. It is not protected one. We will be sharing in the groups. Okay, thank you so much for attending this class, and thank you guys. We'll see you tomorrow. Yeah, take care. Bye bye.
Thank you, bye bye.